An engine is a machine designed to convert one form of energy into mechanical energy. In automobiles, the engine converts the chemical energy stored in fuel into mechanical motion that powers the vehicle. Most vehicles use a type of engine known as an internal combustion engine. In an internal combustion engine, fuel burns inside the engine's cylinders. This combustion produces high-pressure gases that push the piston downward. The movement of the piston is then converted into rotational motion by the crankshaft. This rotational motion is what ultimately drives the vehicle. Before understanding how an engine works, it is important to understand several key terms. A cylinder is the chamber in which the piston moves up and down. The piston is a cylindrical component that moves inside the cylinder and transfers force generated by combustion. Top dead center, or TDC, is the highest position the piston reaches inside the cylinder. Bottom dead center, or BDC, is the lowest position the piston reaches inside the cylinder. The bore is the diameter of the cylinder. The stroke is the distance the piston travels from top dead center to bottom dead center. Engine displacement refers to the total volume swept by all pistons inside the engine's cylinders. It is commonly measured in cubic centimeters or liters. Another important term is the compression ratio. The compression ratio is the ratio between the cylinder's volume when the piston is at bottom dead center and its volume when the piston is at top dead center. A higher compression ratio generally improves engine efficiency and performance. Most automobile engines operate using a four-stroke cycle. These four strokes are intake, compression, power, and exhaust. During the intake stroke, the intake valve opens and the piston moves downward from top dead center to bottom dead center. As the piston moves down, a mixture of air and fuel enters the cylinder. During the compression stroke, both the intake and exhaust valves are closed. The piston moves upward from bottom dead center to top dead center, compressing the air-fuel mixture. Compressing the mixture increases its temperature and pressure, making combustion more powerful. Next comes the power stroke. Near top dead center, the spark plug ignites the compressed air-fuel mixture. The combustion produces high-pressure gases that force the piston downward. This downward motion turns the crankshaft and produces mechanical power. Finally, the exhaust stroke occurs. The exhaust valve opens and the piston moves upward from bottom dead center to top dead center. This motion pushes the burnt gases out of the cylinder. After this step, the cycle begins again. A complete four-stroke cycle requires 2 rotations of the crankshaft, or 720 degrees. Most car engines do not use just one cylinder. Instead, they use multiple cylinders, each with its own piston. In a multi-cylinder engine, the pistons do not all produce power at the same time. Instead, they take turns performing the power stroke, which helps the engine produce smoother and more continuous power. The sequence in which each cylinder performs its power stroke is called the firing order. The firing order is carefully designed to ensure balanced power delivery, smooth engine operation, and minimal vibration. For example, the most common firing order for inline 4-cylinder engines is 1-3-4-2. This means cylinder 1 fires first, followed by cylinder 3, then cylinder 4, and finally cylinder 2. For inline 6-cylinder engines, a common firing order is 1-5-3-6-2-4. By arranging the firing order correctly, engineers ensure that the engine operates smoothly and efficiently. Once the pistons generate power and the crankshaft rotates, that rotational motion must reach the wheels to move the vehicle. The crankshaft is connected to a flywheel, which smooths out the power delivery and stores rotational energy. From the flywheel, the motion is transferred to the transmission system, which adjusts the engine's speed and torque to suit driving conditions. The transmission then sends power through the driveshaft in rear-wheel or all-wheel drive cars, or half shafts in front-wheel drive cars to the wheels. Finally, the wheels rotate, propelling the vehicle forward. This sequence explains how the chemical energy and fuel ultimately becomes the motion of the car on the road. Several key components work together to make this process possible. The cylinder block is the main structure of the engine. It contains the cylinders where the pistons move. The piston moves up and down inside the cylinder and transfers the force produced by combustion. The connecting rod connects the piston to the crankshaft and transfers the piston's motion. The crankshaft converts the piston's reciprocating motion into rotational motion. The cylinder head closes the top of the cylinder and contains components such as valves and spark plugs. The valves control the flow of gases into and out of the cylinder. The intake valve allows the air-fuel mixture to enter, while the exhaust valve allows burnt gases to exit. The camshaft controls when the valves open and close. In petrol engines, the spark plug ignites the compressed air-fuel mixture. The fuel injector delivers fuel into the intake system or directly into the combustion chamber. The flywheel is attached to the crankshaft and stores rotational energy, helping the engine run smoothly. In automotive engineering, engines are commonly classified using several technical criteria. One classification is based on the number of strokes. Engines can be either 2-stroke or 4-stroke. A 2-stroke engine completes a power cycle in 2 piston strokes, while a 4-stroke engine completes the cycle in 4 strokes. Another classification is based on fuel type. Common types include petrol engines and diesel engines. Petrol engines ignite the air-fuel mixture using a spark plug, while diesel engines ignite fuel using high compression. Engines can also be classified according to cylinder arrangement. Common configurations include inline engines, V-type engines, and flat or boxer engines. Finally, engines can be classified based on their cooling system. Some engines are air-cooled, where heat is removed by air flowing over cooling fins. Others are water-cooled, where coolant circulates through the engine and radiator to remove heat. An internal combustion engine converts fuel energy into mechanical power through controlled combustion inside the cylinders. Even though the engine operates in a precise and controlled sequence, small issues can significantly affect its performance. For example, if the air and fuel mixture is not correct, the combustion process becomes inefficient. A mixture that contains too much fuel is known as a rich mixture, while one with too much air is called a lean mixture. Both conditions can reduce engine efficiency and increase emissions. Another common issue is incorrect ignition timing. If the spark occurs too early, it can cause knocking, which may damage engine components. If it occurs too late, the engine will lose power and efficiency. Poor compression is also a critical problem. If the piston rings are worn or the valves do not seal properly, the engine cannot build enough pressure during the compression stroke. This results in reduced power output and increased fuel consumption. Overheating is another major concern. If the cooling system fails, excessive heat can cause engine parts to expand beyond their limits, leading to serious damage. These examples show that the engine relies on precise timing, proper sealing, and correct air-fuel balance to operate efficiently and reliably. By understanding the key terms, the 4-stroke cycle, the main components, and the different classifications, we can better understand how engines operate in modern vehicles. If you enjoyed this video, please like, share, and subscribe. Don't forget to hit the notification bell so you won't miss any of our upcoming videos. Thanks for watching.